In example 3 here, we have solve 2 sine squared x minus sine x minus 1 equals 0. So again, what do I want to do? I want to rewrite this in terms of x's. So I have 2x squared minus x minus 1 equals 0. Again, options to solving this would be to decompose, to use quadratic formula, or to use graphing calculator. So I'm just going to do an option called decomposition. This is back in your 10C days. So right away I have 2x squared. This is going to be minus 2x plus x minus 1 equals 0. Factoring everything out, we have 2x with a x minus 1, positive 1 here with a x minus 1. So we have factors of x minus 1, 2x plus 1 equals 0, and that was just factored using decomposition. Again, sub in right now, so I have sine x minus 1 and 2 sine x plus 1 all equal to 0. Let's set each factor equal to 0, so right here we have sine x equal to positive 1, and over on this side here you have sine x equal to negative 1 half. And now we want to try our best to solve. So sine x is only equal to 1 in one position on our unit circle. That's at x equals 90 degrees. So therefore, this is the same thing as saying pi over 2. Here, sine x is equal to negative 1 half. This happens in two positions on our Cartesian planar, so CAST. We're looking for two positions where sine is negative. That's in quadrant 3 and quadrant 4. So first things first, let's find our reference angle. So our reference angle x, so reference angle here will be equal to 30 degrees, because again, sine inverse of a negative 0.5 should have gotten us negative 30, and there we go. So again, theta is here, so in quadrant 3, we're going to be, and in quadrant 4 there. So quadrant 3 first, we're at 180 plus 30 degrees, so we're at 210 degrees there. And in the second one here, this is 360 minus 30, so that's 330 degrees. But of course, we don't want our answer in degrees, we want to convert both of these. So this one here, 7 pi over 6 and 11 pi over 6, and there you go. We have three answers, three solutions. None of them share the same line, none of them are coterminal. So in part B, state the general solution. We're going to have three of them. So I could say something along the lines of x is equal to, the first one here, let's go with pi over 2, that's our 90 degree one, by the way, plus 2 pi n, where n is an element of an integer. The next one we have, of course, is going to be 7 pi over 6 plus 2 pi n, and as an element of integer again. And last one, x is equal to 11 pi over 6. And there we go. Three solutions, three distinct solutions, three distinct general solutions here. In example 4, it says solve the following. We have secant theta equals cos theta, for theta is an element of a real. So here, let's rewrite secant. This is the same thing as saying 1 over cos theta, and that's going to equal to cos theta. From here, I'm going to multiply out that cos theta, so this is now 1 equals cos squared theta. Of course, moving everything to one side, let's see what we can do. Or actually not even, I can just square root both sides actually right now, so let's throw a radical symbol around here, radical symbol around here, but on the right side, because we put a radical symbol around cos, that's again, consider that a variable. That's the same thing as saying cos theta is equal to the square root of plus minus square root 1. So I'm looking for cos theta equal positive and negative 1. Well, where does this occur? Well, cos theta is equal to positive 1 at theta is equal to 0 degrees and right back at 360 degrees. So if we went in a full rotation, theta is equal to negative 1 only at 180 degrees. There's only one position where cos theta is equal to negative 1. And in this case, it didn't ask us in terms of degrees or radians, so this is perfectly fine for an answer. So let's write down our general solution for something like this. So in general, if you wanted to go from 0 to 360, but you also wanted to get to 180, we can write something along the lines of theta is equal to 0 degrees plus 180 degrees n, where n is an element of an integer, but really this can be ultimately cleaned up to theta equals 180 degrees n, where n is an element of an integer. There you go. In example 5, we have solve sine theta equals roots 3 over 2 for theta to be between 0 degrees and 360, but using technology this time. So we want to try to type this into our graphing calculator, so here we go. So using technology means to figure out what it looks like graphically. Okay. You could have also done something like, well, I have sine inverse of that root 3 over 2. Let's try that again. Sine inverse of root 3 over 2. And of course that's 60 degrees. And so again, you could have used and drawn it out and to figure out that, hey, it's 60 degrees in quadrant 1, and I'll probably have to find something in quadrant 2. But let's see if we can use our graphing calculator to get to that exact same answer. So on our graphing calculator, in y1 I type sine x, close bracket, because x is now theta. In y2 I go square root 3 over 2. Oops. 3 divided by 2. What I want to do is, 1, make sure that I'm in the proper mode. I'm in degrees mode, so that means my windows should be between 0 and 360. Going up by, I don't know, like if we want to go up by 30 degrees, 45, whatever you kind of want to go up by. Our y's, of course, are going to be between negative 2, 2, and I leave it at 1. That's perfectly fine. Right there, we see two intersections. Let's go second trace, option 5. Let's find that first one there. Enter, enter, enter. We have 60 degrees. So that was the first one that we found earlier for sine inverse of root 3 over 2. We do want to find the second one because that's going to be our second answer. And we were predicting that was around 120 degrees. Enter, 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 and look, it actually does check out that it's 120 degrees. So this is what I have on my graphing calculator. So our graphing calculator basically solved this trig equation right there, and it's within our proper window setting 0 and 360. How else could you have written this? So option 1, again, I did y1, y2, so I did y1 equals sine x, and y2 was my root 3 over 2. So that's definitely option 1. Option 2 of typing this in, and we've just found where they intersected, by the way. Option 2 to type this in would be to type everything in all as y1. So y1 would now be sine x minus root 3 over 2, and you could have typed that all in there. Okay, and if you wanted, you'd find the x-intercept now, or you can go y2 equals 0 and then just find the x-intercept where these two lines cross. So that's definitely an option. Option 3, sometimes in case you ever see it as a multiple choice, option 3 would be to type it again all as one line. So this would be y1 equals, very similar, but this time let's get rid of that 2 in the denominator there. So this is now being rewritten as 2 sine x minus root 3. There you go. That's all y1 and y2 again. You could leave blank or use 0 and find where these two lines cross. You'll eventually, of course, get the same answer of 60 and 120 degrees. What are some sets of equations that you could have used that will have the same solutions as the above example? Well, right here, these are the other equations that it's referring to. In example 6 here, it says to use technology again to solve root 3 tan x plus 1 equals 0. So of course I'm going to go y1, y2. So y1, let's go root 3 tan x. Don't forget the bracket there, plus 1, y2 is going to be 0. Our domain in this case here is between 0 and 2 pi, but I can keep that in terms of 0 and 360, and that should be fine. So let's just quickly hit graph, see what happens. So there we go, we have our tangent curve, and right there we are going through our graph 2 times. So again, second trace option 5 there. We want to find this first one here, enter, enter, enter. That's 150 degrees. And let's do that one more time. Second trace option 5 again. Gonna go to the very far right there. That looks like 330. And it is 330. So we have both, we have both of our solutions here. In terms of degrees though, we do want to round it or convert it over to radian. So in this case here, I could say x equals 150 degrees here, and x equals 330 degrees, which I'm going to convert both over to radian. So this is the same thing as saying 5 pi over 6, or 11 pi over 6. And if what they're asking you for the nearest hundredth, that's 2 decimals, you can convert these into radians. So this is the same thing as saying 2.62 rads. And on this side here, 11 pi over 6 is the same thing as saying 5.76 rads. There we go. In example 7 here, using technology, again, we do want to solve for this. Cos theta equals negative 0.25. So let's go straight to our calculator. y1, y2 that. So y1, you have your cos x, and y2, negative 0.25. There you go. And again, our domain for this one here is between 0 and 2 pi, not including 2 pi. But what I want to do is I'm going to do this in terms of degrees and then convert to radian. So my first answer here is right there. Enter, enter, enter. I'm looking at approximately 104 degrees. So this here is a little ugly. It didn't work out nicely, so I am going to just switch right over to radian on this one. So with radian, I'm changing my window between 0 and 2 pi. And let's go up by pi over 6, which is the same thing as 30 degrees. And again, of course, we get the same graph, but this time I get my answer right away in terms of radian. So my first intersection is 1.82 rads. And my second intersection here, let's go. There we go. Enter, enter, enter. 4.46 if you had to round it, radians. 4.46. So let's just quickly jot down our answer for theta. So here I have theta equals 1.82 rads for radians, and theta over here is equal to 4.46 radians. There we go. And we have our last question for today. We have find all solutions for x divided by 2 minus 2 sine 3x equals 0. This one here, by the way, is a radian question. I want to be in radian. Okay. And so let's set up our window here. So find all solutions. So let's type in our equation first. So we have x over 2 minus 2 sine 3x. 3x there is all going to be together, and in y2, 0. So my window setting. I believe I have a proper window setting here, but just to make things a bit bigger, because we want to see all our solutions, we probably want to see a little bit here in the negative side as well. So this is all from 0 to 2 pi, but we want to see all solutions. So let's start from negative 2 pi, going up to 2 pi there, going up by 30 degrees or pi over 6. So my window setting, this is what it is. And here is my graph. There you go. And that's, you kind of see why I made my window a bit bigger, because now I can see all my solutions. I have 2 here, 2 right here, 2 right here. So I got 1, 2, 3, 4, 5, 6, 7, 7 solutions in total that I want to write down. And again, what do? Go second trace option 5 and find every single one of these little x-intercepts here. So I'm going to list off all my x values to about 2 decimals each. So x equals, the very far left is negative 2.87 radians. And then you have negative 2.30 radians. So that's these two right there. You have this one right here, which is, where am I, negative, wait, where am I? Sorry, I'm just going to double check this one here on my graphing calculator. Yep, so that's negative 0.97. There we go. Negative 0.97 radians. And so the next one follows. That's right at 0 radians. Then we have our positive answers. So we have 1, 2, 3 that are positive. So you have positive 0.97, positive 2.3, and of course positive 2.87 radians. And here, this is again strictly done on graphing calculator with all our solutions for x there, because x is only crossing, our graph is only crossing our x-axis in these 7 particular positions. If you have any questions about today's lesson, please feel free to ask.